Hi, everyone. Welcome. So, what we're going to do today is go through the scientific method cheat sheet again and recap kind of some of the things we talked about in our lesson. So, to start, we're going to talk about our different kinds of variables. The first is our independent variable. So, our independent variable. All right. The independent variable is the variable that I change during the experiment, and there should only be one. This is super important. There are many things that could affect this little plant's growth over here, but we want to make sure that the only thing we're changing is the amount of water we're giving it. If we change the soil, the size of the pot the plant is planted in, the amount of sunlight it is receiving, these all could go into changing the outcome. And so we want to make sure that we only change one of these factors. So if our hypothesis for this, and I'm going to write our hypothesis in green down here, is if given more water, then the plant will grow taller. We can test this hypothesis with the experiment on the right. Okay? In our hypothesis, the independent variable we are using is the water. Okay? So, for that purpose, I'm going to highlight the watering can and label it independent variable, marking it IV, so we know that that's our independent variable in this experiment. Okay? We could change a lot of other factors in this as well, but remember, you only change one, and for this purpose, given this hypothesis, the water quantity is what we are changing. Okay? So now we are moving down to dependent variable. This is the change that happens because of the independent variable. All right? So it's what you are measuring. This is our measuring portion. Okay? So if we look back up here, I'm going to lasso this and just scooch it down with us. Okay? What is our dependent variable in this problem? Okay? Our dependent variables. So when asked that, I want you to think of what one can we measure and what is the effect of this prediction. So if given more water, then the plant will grow taller. That then is a really good hint that the dependent variable is following after. It grows taller. So the height is going to be our dependent variable. So with that, we're going to highlight this ruler. It does not highlight well with the software I'm using, so we're going to just shimmy that down. It's the highlight, the ruler, sorry, my apologies. Okay, and measuring the plants. So that is our dependent variable. We are measuring the height of the plant as it is given different amounts of water. So we would have many trials of this, meaning many plants in many different pots. And we would give 3 pots no water, 3 pots maybe a cup of water, another pot, 3 pots, 5 cups of water, and then 20 cups of water for the last to see how the amount of water affects the plant's growth. Okay, so let me lasso this guy again. There we go. Drag this down. Okay, so now we're going to talk about the controlled variable. Well, actually, it's going to be more, we're going to call these what are constant variables, what we need to make sure we keep constant during our experiment. So our constant variables. It's the variables, like I said, that remain constant and unchanging to make our experiment valid. If we changed the sunlight and the amount of water, then we can't accurately state that it was just the water that caused the plant to grow taller. It could also be the sunlight if it was given more sunlight. So the things that we keep constant have to be other things that might affect and cause changes in the dependent variable. So with that, let's mark these in, let's pick a fun color. Let's do blue. So we're going to mark our constant variables in blue. So our sun, this is not going to look pretty, but our sun is a constant variable when our independent variable is the water. It is also not only the soil, but the pot size. So I'm going to specify that. So it's soil and pot size. Ooh, okay, we'll just start in the middle of the word and spell it out from there. Okay, and then the sun. So these are all different constant variables. In class, we talked about CO2 content in the air. So we breathe out CO2. Plants actually breathe that in, use it to build sugars and make their own food, which we'll talk about when we get to photosynthesis. And then they expel or exhale, which they do not exhale, but release O2 for us to breathe in. It's like the circle of life. Okay, so CO2 content is also really important. If we put this plant in a jar, it would eventually use up the CO2 available and suffocate. And so that would definitely affect growth. So all in all, the constant variables, we want to make sure we keep them constant through all the different trials we're doing to make sure that it is only the independent variable, or our water in this case, affecting the height of the plant, affecting whether or not it will grow taller. Okay? So moving forward, we're going to talk about the scientific method. 3 big ideas that we want to make sure that are clear. Okay? It is hypothesis, theory, and law. A lot of the time, people use hypothesis and theory interchangeably, and they do not mean the same in science. A lot of the time you'll hear in conversation with others, I have a theory about this, and then they will go on and state their prediction. A theory, however, is not a prediction. It is an explanation of why something happens. Okay? And it is supported by many hypotheses. So it is not proven, but it is supported by many hypotheses. Okay? And that word is hypotheses. That's plural. Okay? If new information comes out, it can be rejected. That's the crazy thing about this. Is long ago there was the atom theory that stated it was believed that the atom was the smallest unit of matter. Well, then one day they broke it apart and a bunch of little subatomic particles came out, and that was new findings that debunked that theory. In the next video, we will continue.